Okay. So, hi everyone. I'm Chi from VMware, and I'm happy to be here to tell you about our effort to bring Kubeflow to VMware software platforms. There will be two parts of this talk. The first one is about the some like background information of this effort, mainly focus on the machine learning visions and strategy at VMware and how we like integrate Kubeflow into the whole VMware machine learning stack. And in the second part, I will dive into some like details of Kubeflow VMware distributions, such as how we improve the Kubeflow lifecycle management on vSphere and the TKG platform, and how we like improve the GPU resource management based on Kubeflow and vSphere, etc. All right. Let's start from some like background. This is the like VMware private AI reference architecture just announced in several weeks ago in the VMware Explore of this year. So the key part of the reference architecture for VMware is a cloud foundation at the bottom, right? So we have like also have some like a core capabilities in vSphere as well that sits above that. So the deep learning VMs in terms of embedding some more capabilities to like give you your the VM appliance that are ready already pre-configured for AI and machine learning workload. So whether there is drivers or libraries from hardware vendors, whether it's your popular machine learning framework pre-installed, ready to go, it's just gonna increase your time to value, which is really what we are going for there. The VectorDB database, so far we have been working with Postgres and the PG Vector. Also, as you know, that VMware is Green Plum. And the GPU scaling, one hand is like already taking advantage of the native capability that NVIDIA provide. And for example, the NVLink and the NVSwitch to allow you to aggregate more GPU into one VM. In other hand, we are using like TKG auto scaling to improve the GPU resource management and scheduling. I will mention the details later in these slides and how to like enable these features in Kubeflow. And finally, the vSAN FastPass has give you a direct access from your vSAN storage to the GPU bypass the CPU pass. So above that, we have like three key components, which is Ray, Kubeflow, and PyTorch. First, with this integration, so it will be much faster that the way that trying to do with some manual integration with vSphere. And it's also that we could bring some like most advanced infra management technology, such as I've mentioned that auto scaling with GPU capabilities with this and together with this open source software and VMware stack. So we could see that Kubeflow is in the central position as it one of the like most popular open source machine learning workloads orchestrator today. So that is also being part of our motivation is that this is a great technology. We want to get behind it, contribution to this project, make it better, help our customers to bring it on premise with vSphere and also VMware clouds. And that's being our direction there. And this page show like some more details information, more detailed information about this baseline reference architecture, including some of the key benefits, which it could be like shorten the time to result, reduce the complexity of system design, testing, validation, deployment, and configuration. It's also a trusted deployment. As I've mentioned, that the components in the stack are selected carefully, and we have validated this combination in our testing pipeline and also production environment. Also assist with the technology brought by underlying infras. We could max the resource utilization and reduce the time to support different organization on a common base platform. As I have mentioned that there will be a demo later in this talk, we will use the Kubeflow and GPU auto scaling technologies provided by vSphere and vSphere Tanzu to show that cap. And also it's a flexible infrastructures, which means that we could run like all AI and machine learning workload on a common on-prem VMware cloud infrastructure stack. So in the past several years, as underlying infrastructure and also like some system software providers, we have like helped lots of our customers to build their AI infras. With that journey, we have learned some experience and lessons. So when we build the Kubeflow solution based on VMware Stack, we always keep the above principles in mind. To summarize, like a modern AI and machine learning infrastructure will be need to first it need to be agile. It means that rapid response to the request from like data scientists and machine learning engineers for the acceleration and co-processors anytime and anywhere. So later in this talk, I will show a demo that how we leverage Kubeflow and GPU management capabilities provided by vSphere Tanzu to rapidly response request from these personas. And also the second one is efficient. So you know that the AI servers with GPU resources are main cost for AI and machine learning workloads, especially for the large language model ones. So it's really important to increase the overall utilization and efficiency, also reduce these operational costs. So the third one is that ease of integration, which means that the deployable with no disruption of current infras, seamlessly integration to work to existing and our customers' workflow and life cycles. We have listened that some like small or even trivial changes to our customers' existing workflow will lead to the failure of this whole project. Last but not least, scalable. As you know that the technology of machine learning software and hardware are growing fast, and also requirements are changing rapidly. So they will need the extensibility to support an ending cloud and even an ending edge environment. So okay, so with those background information, our vision is to like build the machine learning services based on Kubeflow on the VMware software stack. So in the in the following section, let's take a look at some details about this effort, this Kubeflow VMware distribution. So with Kubeflow, as all we know that it's possible to cover the whole machine learning data model and application pipelines. So, and also by leveraging the strategy and the capabilities of VMware clouds, we are bringing Kubeflow to the multi-cloud area. You could run Kubeflow on private clouds, and I mentioned that with vSphere product, and also can run Kubeflow on public cloud, such as AWS, GCP, Ali Cloud, etc., with VMware VMC and also VCPP program, and even around Kubeflow on edge clouds with VMware TKG Edge products. So all those targets could be achieved with vSphere and vSphere with Tanzu. So to achieve that, we have like built a Kubeflow VMware distribution since Kubeflow version 1.6 and maintain it as a official open source project and a VMware organization on GitHub. And we released this distribution by with Kawel package. So users could receive all like benefits brought by this Kawel packaging, such as easy of deployment, observability, resource grouping, etc. And this open source project and packages could be found on Kubeflow official website, as well as the website of VMware Marketplace, which is a like a distribution of some cloud native and other VM packages officially supported by VMware. So these slides show like Kubeflow covers the like 4 stages of machine learning lifecycle by leveraging lots of lots of different open source machine learning relevant components, and the way it interact with the like underlying infrastructures, including hardware and software such as VMware, vSphere, and other like system software and other Kubernetes distribution, etc. So we are not just doing the Kubeflow Kawel packaging to only enable Kubeflow only could running on vSphere VMware software stack. We are trying to do the deeper and further integration with VMware software stack and technologies to achieve like by better user experience. So these bullet items summarizes what we have done for today for VMware, for this VMware Kubeflow VMware distribution so far. And this label show which component is how related to these items. For example, the like I have mentioned that the Kawel packaging and the Kubeflow supervisor service, the enhancement to like to Kubeflow and vSphere to improve the GPU observability, scheduling, and management. I will detail this 2 parts later in this talk. Other effort also include some vSphere integration with like object storage, the integration with MinIO and vSAN, and also the Kubernetes device plugin, also the GPU operator support to like vSphere Tanzu, and also the integration of API gateway with TKG. I will not go into some like details due to the limited time here. So first, I will talk. I will take the lifecycle and the GPU management as a detailed example in the rest of the talk. So for the lifecycle management, for now we have as I mentioned that we have released the Kubeflow VMware distribution as Kawel package. So our customers could deploy and manage the lifecycle for Kubeflow installation instance as one whole package. This would reduce the complexity of deployment, configuration, and the management effort greatly. For example, now with the Kawel package, you could manage the deployment options within just one single config file or place. You could handle the like build to build upgrade. We have like do some like full coverage test to to this version-to-version upgrade, etc. All these benefits are brought to you by this packaging. Besides, with vSphere with Tanzu platform, we even built a Kubeflow supervisor service. I will introduce some details about this supervisor service. So you even just only need one liner of bash code to shell code to deploy and management this whole Kubernetes clusters and Kubeflow on it. So as I mentioned, that I will describe this feature in the next page, and also a demo to show the capability of these features. So with this effort, we even could provide much more powerful and friendly user experience on VMware Cloud Stack. For example, from this table, you could see that we could shorten the deployment time from days before this effort, because without this effort, if you want to run in Kubeflow on the TKG platform, you really need to fix some issues. So that maybe takes you days to do some debugging and the code fix. We can shorten this deployment time to less than 1 hour, which also, as I mentioned, that even includes the deployment of Kubernetes cluster itself. So in the future, also we want to plan to create a CCI service. CCI is a cloud common interface and platform to deploy Kubeflow platform to VMware Cloud via SaaS models. So our customer and cloud partners could have even SaaS options based on Kubeflow. So this page shows the architecture of Kubeflow supervisor service on vSphere with Tanzu. So supervisor service are some vSphere certified Kubernetes operators that could even deliver the infrastructure as a service components and tightly integrated ISV services such as Kubeflow to our developers, to the DevOps team. So you can install and manage the supervisor service on vSphere with Tanzu environment, so that make them available for use with Kubernetes workload. So when supervisor service are installed on supervisor clusters, DevOps engineers and our even developers can consume them in two ways. The first is a shared supervisor service, directly provide the functionality to workloads running in the TKG cluster, for example, the vSphere pods or even a VM. So in that hand, the supervisor service that include an operator, for example, a simple, for example, such as admin.io, which could provide API or UI interface, which a DevOps engineer can use to create or manage an instance of the service in a vSphere namespace through CRDs. So, for example, to create a MIO bucket, you could use this CRD to create a bucket in a vSphere namespace. In our Kubeflow example, with this Kubeflow supervisor service, and the users, our developers, our DevOps engineers could deploy the Kubernetes cluster and the Kubeflow instance with CRD user experience. So all these completed steps to deploy and set up the Kubernetes cluster. For example, you need to want to configure and enable a Kubernetes cluster with GPU support, right? Can be simplified to just one liner of the kubectl. So the following is a demo to show these caps.
We are here introducing a supervisor service that can deploy a unified TKG with Kubeflow installed. This is the namespace where we would like to deploy a cluster with Kubeflow installed. Note that there is currently no cluster existing. VI admin needs to first register the supervisor service on vCenter by navigating to namespace services. Add a new service and upload the YAML file which defines our Kubeflow supervisor service. After registration, admin should see card updates on vCenter UI. Admin then install the service on supervisor cluster. Okay, supervisor service is up. Admin only needs to above register supervisor service work once. Now, we, as developers, can start to create this customer resources file. Besides authentication information, we need to specify the TKG spec. Supervisor service will check the existence of the cluster, and if not, which is our case, a new unified TKG with Kubeflow installed will be created for us. Let's apply and wait for the completion of reconciliation. After a while, we can see the UTKG with Kubeflow is up. If we log in to the UTKG, we can see Kubeflow 1.6.0 is in the list of installed kernel package. We can then go to the browser and enjoy Kubeflow.
Okay, as we can see that it's very easy for our end user customers to deploy such of kind of instance of Kubeflow, right? So in the next several pages, I will talk about our effort to improve the GPU management of Kubeflow based on vSphere Tanzu with vSphere platform. As you may know that vSphere Tanzu brings two layered resource scheduling and management capabilities. So the lower layer is a virtual machine and the DRS dynamic resource scheduling based, so which is provided by vSphere and vSphere, right? So the GPU resources also could be virtualized and management by vSphere as we does to CPU and memory resources with different kinds of GPU virtualization technologies, such as, for example, the NVIDIA MIG from NVIDIA, and even some software virtualization technologies. For example, maybe you have heard that VMware had a technology called bFusion, right? The up layer is Kubernetes-based provided by TKG by a Kubernetes distributions. So we further extended these capabilities of this layer to better support the AI and the machine learning workload. For example, the autoscaler support for GPU resources, which usually appears in the public cloud. The GAN scheduling support, and also the topology aware scheduling, etc. And these are some background information before we talk about how to enable this the advanced GPU management features for Kubeflow. And for now, as you know that the machine learning platforms are not most of these machine learning platform and these underlying infras are not aware of the underlying, for example, vSphere GPU resources, and could not issue a request for dynamic GPU resource because of lacking of this GPU interface and services, right? So for the case of Kubeflow, let's take a look at a running instance of vanilla Kubeflow, right? For example, if the data scientist want to start a notebook with GPU resources, he or she only could issue this request without any without any detailed GPU fragmentation and the GPU information, right? So another common situation that if the data scientist using Kubeflow want to request a unconfigured GPU fragment on vSphere, he will need to go through all these manual steps with the help from different personas, right? So this data scientist will need to issue ticket to request the needed GPU resource. Then the VI admin may be take some steps to to like create or set up the VM class and the VM class bindings for this request. And our DevOps team will configure this TKC resource, which create new Kubernetes nodes. And finally, the data scientist can get the resource to run this workloads, right? So all these steps are very complex, and which because of this manual step, they are also very low efficient and also error prone. So with the demo I will show in the next page, with today's GPU service demo, I will show that a GPU service which could fully automate this process and simplify this workflow. So it could improve this overall efficiency greatly, shorten the whole process from hours, even days, to like just about less than half an hour. Let's take a look at the demo.
First of all, we customize the notebook creation page to display the stats of GPU usage information. For example, here, for now, there is one available 4 GB GPU, but 0 available 8 GB GPU. So let's create one notebook server with NVIDIA A24C. Run command NVIDIA SMI, and you can see this notebook server indeed has one 4 GB GPU. Now, back to the new notebook page, you can see that there is no available 4 GB GPU anymore. Besides, to dynamically allocate GPUs based on users' needs, we integrate our Freestone Kubeflow with Kubernetes Cluster Autoscaler. Here, the autoscaler GPU target represents the target number autoscaler is adjusting to, and this autoscaler GPU range represents the minimum and maximum number of GPUs that can be scaled up or down. Let's start the autoscaler. Now, there is no available 8 GB GPU in the cluster, but let's say the user really needs to have one 8 GB GPU for the work. Create one notebook server with NVIDIA A28C. Back to the new notebook page, you can see that the target of 8 GB GPU becomes 3, meaning that the autoscaler is scaling up the number of 8 GB GPU to satisfy users' needs. This notebook would be in pending state while waiting for the scaled-up GPU to be ready, and users can also track the scaling up process in vCenter. And let's say after the work, the user would like to free the GPU to save resources. Delete this notebook. After deletion, open the new notebook page again. You can see that now the number of NVIDIA A28C is scaled down to 2 again.
Okay, that is the GPU part. And the last thing I want to mention is that array and the potential integration with Kubeflow and vSphere. So as we have announced in the VM Explorer, and as you know that we spend a lot of time with any skill or working on array in particular, because this array just for us, it gives you a very like a quick on-ramp to a variety array of different AI projects, especially in the large language area, and also supported in array, right? So we have implemented a array-based, a VM-based array backend, and also we have validated the kubearray could work smoothly with the TKG and vSphere with Tanzu, and then even better, array could work with TKG autoscaler, like to achieve these two layered auto scaling as shown in the in this page. So we also see some initial and interesting effort on the integration between Kubeflow and array, for example, the UI integration, etc. So this provides some more potential opportunities to further extend the integration of Kubeflow and the vSphere. So I'm looking forward to working with the Kubeflow community on this subject. Yeah. Okay, that is pretty much of my today's talk. I'm glad to have this opportunity to meet the community, and also thanks for your listening. Any questions?
Any questions, anyone?
I hope you can hear us, right?
Not really well. You might want to come. Let me get the mic. Let me just get the mic for you. I think we have one question. Let me get the mic to them.
Thank you for the great talk. I have a question. You mentioned that in VMware you have a Kubeflow instance to run training, and you have array also. You mentioned today. So I'm just wondering, in terms of the user story, I know that Ray has trained tune components, right? They have the ability to start as Ray clusters on Kubernetes. So I'm just wondering, what is the differences you see, and when you choose one over another? Thank you.
Yeah, so it's like some removing. So I'm just checking with you that if I understand the question right. So your question is ask why we choose Ray, right?
Yes.
Yeah, as I
Yes.
know that frankly speaking, VMware is not a like a new player in this machine learning area. So as we know, I have mentioned in this talk that we see lots of applications on this machine learning area are built with Ray, especially in the large language model area, and also like that we have some very cooperation relationship with Ray's like commercial company Anyscale. So Ray is definitely one of the ecosystem we want to bridge to like grow a better ecosystem machine learning application on it. So, I'm just I'm talking about Ray, but actually, VMware is looking for ISV partners, not just focusing on just one ecosystem or one company. For example, this GPU auto scaling features, we are working with DCube. Is also is one of these companies that build their solution based on Kubeflow, right? So to work together to bring these new features to the to our customers and also to the community. Yeah.
We've got one more question.
Very interesting talk. Just curious for the GPU display in the notebooks, is that sort of tied to VMware? And if not, are you looking to potentially contribute that back? Because that would be great.
Yeah, actually, those kinds of as you know that autoscaler and Kubeflow are open source, right? And are using this autoscaler scalar features enabled for the GPU, but also we have contribute this source code to the upstream communities. So all these features, including what we have done as a code improvement to Kubeflow, we want to contribute this code back to the upstream and also the community. We work, as we even mentioned, that also we work with DCube, that we work with them in this mechanism that we work together in this open source community mechanism. Yeah.
Thank you so much. We appreciate you coming and look forward to your contributions in the future.
Okay. Thank you.